welcome back to Tech and EduSpark Hub, where technology meets education. In today's video, we'll be looking at the percentage composition of elements in a compound. This topic is essential in understanding stoichiometry, solving chemical calculations, empirical formula and molecular formula, and solving a lot of UTME questions. So stick with me till the end and let's enjoy the best out of the lesson. By definition, the percentage composition of elements refers to the percentage by mass of each element present in a compound. So this is a simple definition of the percentage composition of elements in a compound. It refers to the percentage by mass of each element present in that compound. For example, let's say we have the compound NaCl, which is known as the sodium chloride. So you can see this compound, which is the sodium chloride, is made up of sodium and it is also made up of chlorine. So what this percentage composition does is that it tells us what amount of sodium makes up this compound and what amount of chlorine makes up this compound in percentage. So maybe you can say 15% of sodium is in this compound, and also maybe like we can say 85% of chlorine is in that compound. So this is what just the percentage composition is telling us about. It makes us know the percentage of each element present in a compound. And one thing to note is that the percentage composition of any compound must be equal to 100%. So the percentage composition of any compound must be equal to 100%. This is just an assumption because I'm just using this 50% and 85% as an example. So let's say like 15% of sodium is making up this sodium chloride and 85% of chlorine is making up this sodium chloride. So if you add this percentage together, you must get 100%. So this is what the percentage composition is telling us about. Next up, we'll be moving to the basic formula of the percentage composition. So let me just write that down. We have the basic formula. So the basic formula of the percentage composition is given by a percentage of elements is equal to the mass of that element divided by the molar mass of the compound multiplied by 100%. So this is the basic formula of the percentage composition. It is given as percentage of elements is equal to the mass of the element divided by the molar mass of the compound multiplied by 100%. So we have steps by steps in solving this percentage composition of elements. So I'll be writing the steps down because when we get to the calculation aspect, it is these steps that we follow to solve our question under the calculation aspect. So let me just write the steps down. So here are the steps to follow when solving questions under the percentage composition of elements. So the first step is to write the correct chemical formula. So let's write that as step 1. So the first step is to write the correct chemical formula. We can write e.g. So we can have H2O, CaCl2, and so on. So what these steps is basically telling us about is that we have to make sure we write the correct chemical formula in order to solve percentage composition of elements in a substance. So moving to the second step, we have the step 2, which is to find the atomic mass of each element in the compound. So what this step is basically telling us about is to find the atomic mass of each element present in that compound. And we have the third step, which is the step 3, which is to calculate the molar mass of the compound. So the third step, which is the step 3, is to calculate the molar mass of the compound we are working with. And moving to the fourth step, we have the step 4, which is to find the contribution of the mass of each element in the compound. And the last step, which is the step 5, is to apply the percentage formula. So these are the 5 steps to follow when calculating the percentage composition of mass of elements in a compound. So the first step is to write the correct chemical formula of the compound. So you can write the correct formula. You can have H2O, CaCl2, NaCl, so on and so forth. And the second step is to find the atomic mass of each element in that compound. So you can find the atomic mass of H in this compound, atomic mass of Ca in this compound, and so on and so forth. And the third step, which is to find the molar mass of the compound. So you have to find the molar mass of the compound itself. And the fourth step is to find the contribution of mass of each element in the compound. So you can find the contribution of hydrogen in this H2O, find the contribution of oxygen in this H2O, and lastly, the fifth step, which is to apply the percentage composition formula. So having known all these steps, let's look at questions under the percentage composition of elements in a substance. The first question, as displayed on the screen, says that the percentage composition of an element in a compound depends on its A. atomic number, B. atomic mass, C. valency, and D. physical state. So in this question, the question is asking us that the percentage composition of an element in a compound depends on its what? So we said we have to find the atomic mass of each element in the compound. So it depends on the atomic mass of each element in the compound. So atomic mass is correct to this kind of question. And the second question, as displayed on the screen, says that the percentage of oxygen in water, H2O, is. So in this kind of question, we are asked to calculate the percentage of oxygen in H2O, which is water. So in this case, we have to follow our steps. So the first step is to write the correct chemical formula of the compound we are working with. And the question has already given us the chemical formula, which is H2O. So this is the first step, to write the correct chemical formula, which is H2O in this case. So we have the H2O. So the question has already given us the chemical formula. And the second step is to find the atomic mass of each element in the compound. So what are the elements in this compound? We are having hydrogen and oxygen in this compound. So what is the atomic mass of hydrogen? The atomic mass of hydrogen is 1, and the atomic mass of oxygen is 16. So this is the atomic mass of the elements in the compound. And moving to the third step says we have to calculate the molar mass of the compound. So to calculate the molar mass of the compound, which is H2O, so we have to calculate it by using the atomic mass. So in this case, we are having the atomic mass of hydrogen to be 1, multiplied by what is the mass contribution, which is 2. So the mass contribution is 2, plus what is the atomic mass of oxygen? The atomic mass of oxygen is 16. So the molar mass of the compound, which is H2O, so this will be 2 plus 16, which will be given as 18. So the molar mass of the compound is 18. So we have completed the third step. And moving to the fourth step, it is asking us to calculate the contribution of the mass of each element in the compound. So in this case, we have to calculate the contribution of the mass of the elements we are asked to calculate in the question. And the question is asking us to calculate the mass contribution of oxygen in this question. So to calculate the mass contribution of oxygen, we know that the mass contribution of oxygen is 16. So we can say mass of oxygen is equal to 16, because we are only having 16 here. But assuming the question is asking us to calculate the mass contribution of hydrogen, we are going to multiply the atomic mass of hydrogen multiply by the mass contribution, which is 2. So the mass contribution of hydrogen will be 2, but oxygen here is having just single atom with no mass contribution, unlike oxygen that is having 2 in this case. So that is why we are using the mass contribution of oxygen to be 16. So this is all about the step 4 formula. And moving to the last step, which is the step 5, it says we should apply the percentage composition formula. So applying the percentage composition formula, the formula says percentage of element equals to mass of the element divided by the molar mass multiplied by the 100%. So you can say the percentage composition of the oxygen that we are trying to work with. You can say percentage composition of oxygen, because the question is asking us to calculate oxygen. So it will be equal to, what is the mass of oxygen, which is the mass of element. So the mass contribution of oxygen in this case is 16. So we have 16 divided by, what is the molar mass of the compound that we are trying to work with? So the compound is H2O and the molar mass of the compound is 18. So you have 16 divided by 18 multiplied by the 100%. So this is the 100% that we are talking about. And when you divide this, you have percentage of oxygen will be equal to 16 divided by 18 will give you 0.88888 multiplied by 100%. So 0.888 multiplied by 100 will give you 88.89% on approximation. So 0.8888 multiplied by 100 will give you 88.89% on approximation. And this will be given as our final answer to question of this type. Moving to the third example, as displayed on the screen, the question says, what is the percentage of carbon in CO2? So in this kind of question, we will be given the correct chemical formula, which is CO2. So step 1 is done like that. So we have been given CO2 in this case. So that is the step 1. The step 1 is to write the correct chemical formula, and which the question has given us to be CO2. So step 1 is done in this case. So the step 2 is to find the atomic mass of each element in the compound. So looking at this compound, what do you think make up this compound? So we have carbon and oxygen that makes up this compound. So the atomic mass of each element in the compound. So the atomic mass of carbon is 12, while that of oxygen is 16. So this is the atomic mass of each element in the compound. So now that we have gotten the atomic mass of each element in the compound, we have to calculate the molar mass of the compound. So to calculate the molar mass of CO2, we just have to find the mass contribution. So this will be 12, which is for carbon, plus open bracket. You can see that this oxygen is having 2, unlike water that we deal with in the other time. It is only having single oxygen. But here we are having O2, so we have 2 multiplied by the 16, which is the atomic mass of oxygen. So the molar mass of CO2 will be given as 12 plus 32, which will be equal to 44. And this is the molar mass of the compound that we are trying to work with, which is the CO2. So we are done with step 3. And moving to step 4, it says find the contribution of the mass of each element in the compound. So this step 4 is asking us to find the contribution of mass of each element in the compound. But in this case, the question is asking us to find the percentage composition of carbon in this question. So we are only looking for the mass contribution of carbon. So looking at this compound, the mass contribution of carbon will remain the atomic mass of carbon because it does not carry any number. But assuming they are asking us to calculate the mass contribution of oxygen, this will be equal to 16 multiplied by 2. So the mass contribution of oxygen will be equal to 32. So in this case, the mass of carbon will be equal to this 12. So that is all about the step 4. So we are only working with the mass of carbon because the question is asking us to calculate the percentage composition of carbon in the compound. So we'll be moving to this 5th step, which is the step 5, which is to apply the percentage composition formula. So we know that the percentage composition of elements is equal to the mass of elements divided by the molar mass times 100%. So we are working with carbon. It will now be percentage composition of carbon. So we have the percentage composition of carbon, which is the element, is equal to, so what is the mass of elements? So the mass of elements is the mass of contribution of that element, which is 12, divided by, so we have the molar mass of the compound, which is 44 in this case, times 100. So the percentage composition of carbon will be given as, so 12 divided by 44 will give you 0.2727. So we will now multiply this by 100. So the percentage composition of carbon will be given as 27.27. So 27.27% is correct to this kind of question. So this is given as our final answer to this kind of question. Let's say we are to ask to calculate the percentage composition of oxygen in this case. So what we just have to do is to look for the mass contribution of oxygen. So looking at the mass contribution of oxygen, mass contribution of oxygen will be given as this 16 multiplied by this 2 because we are having CO2. So 16 multiplied by 2 will be given as 32. So 32 divided by 44, which is the molar mass, multiplied by 100. So assuming we are asked to calculate the percentage composition of oxygen in this case, we are going to use the percentage composition of oxygen equal to the mass of oxygen divided by the molar mass. And that is why we have 32 divided by the molar mass multiplied by 100. So the percentage composition of oxygen will be given as this 16 multiplied by this 2. So we have 32 divided by 44 divided by 100. And when you divide this, you have 0.7270 multiplied by 100. So when you multiply this, so the percentage of oxygen will be given as 72.70%. So when you add these two together, you must get 100%. So let's add these two together and see what it will give us. So when you add it, you must get something like 99.97. So this is approximately 100%. So this is how the mass contribution of elements or the percentage composition of elements works. You just have to know the contribution of that element with the atomic number of the element and the molar mass of the compound. So that element, you have to find the mass contribution by using the atomic number divided by the molar mass of the compound multiplied by 100%. So if that element is like CO2, you have to multiply 2 times the atomic number divided by molar mass multiplied by 100%. So this is all about the third example. So let's move to another question under the percentage composition of elements in a compound. And moving to the next question, the question says the sum of percentage composition of all elements in a compound is always A 50%, B 75%, C 100%, and D 200%. So this question, I said earlier that the percentage composition of all elements in a compound must be equal to 100%. So 100% is correct to this kind of question because you can see that when we had this oxygen percentage composition and this carbon percentage composition, you can see we get 100% as our final answer. So this is correct to this kind of question. So 100% is correct, which is the option C. The percentage composition or the sum of the percentage composition of all elements in a compound must be equal to 100%. So 100% is correct to this question. So let's move to the last question under the percentage composition of elements in a compound. And to the last question, the question says the percentage of sodium in sodium chloride is approximately. So in this kind of question, we are given the compound, which is sodium chloride. And the question has already given us the formula for sodium chloride, which is NaCl. So this means that we have already completed the first step, which is to write the correct chemical formula of the compound we are trying to work with. So the question has already given us the correct chemical formula for sodium chloride, which is NaCl. So to the next step, find the atomic mass of each element in the compound. So in order to find the atomic mass of each element in the compound, the atomic mass of sodium is given as 23 and that of chlorine is 35.5. So this is the atomic mass of sodium and this is the atomic mass of chlorine. So once you know that, move to the next step, which is to calculate the molar mass of the compound. So in order to calculate the molar mass of the compound, we have NaCl to be equal to, so this is 23 plus 35.5. So NaCl is equal to 58.5. So the molar mass of NaCl is given as 58.5. So that is all about the third step. So moving to the fourth step, we have to find the contribution of the mass of each element in the compound. So in this case, we are looking for, the question is asking us to find the contribution of sodium in sodium chloride. So we are only going to work with sodium in this case. So the mass contribution of sodium in this case is just 23 because it does not carry any number. Assuming it carry any number in any element, you have to multiply that atomic mass by that number to find the mass contribution. But in this case, it is not carrying any number, so we are just having 23. So the mass of sodium, which is Na, is given as 23. Now that we have gotten the mass of sodium to be 23, we can then move to the fifth formula, which is to apply the percentage composition formula. So remember we said the percentage composition of elements is equal to mass of elements divided by molar mass of compound multiplied by 100%. So in this case, the question is asking us to calculate the percentage composition of sodium in the compound NaCl. So we'll be using the percentage of the sodium that we are asked to calculate. So we have percentage of sodium is equal to, so what is the mass of elements? We said the mass of sodium is equal to 23. So we have 23 divided by, so what is the molar mass of the compound? So the molar mass of the compound is 58.5 multiplied by the 100%. And when you divide this, when you divide 23 divided by 58.5, you have 0.3931 multiplied by 100. And our final answer, which is the percentage of sodium in this compound, will be given as 39.31%, or approximately as 39%. So 39% is correct to questions of this type. But assuming we are asked to calculate the percentage composition of chlorine in this case, we are going to use the mass of chlorine divided by the molar mass of the compound. So for example, let's calculate the percentage composition of chlorine in this case instead of percentage composition of sodium that we did earlier. So percentage composition of chlorine will be given as, what is the mass of elements? The mass of elements will be given as 35.5 because chlorine is not carrying any number. Unlike this CaCl2, you can see chlorine is having 2 in this case. So the mass contribution of chlorine in this case will be given as 2 multiplied by this 35.5. But just because chlorine is not carrying any number in this case, the percentage composition of chlorine, so percentage of Cl, will be given as, so this 35.5 divided by 58.5 multiplied by 100. So when you divide this, you have 0.6068 multiplied by 100, and the percentage of chlorine will be given as 60.68%. So if you are asked to calculate the percentage composition of chlorine in this case, this is what you are going to get. But just because we are asked to calculate the percentage composition of sodium, that is why we are getting 39%. And I said when you add the percentage composition of each element in a compound together, you must get 100%. So let's add the percentage composition of this element, which is chlorine, with the percentage composition of sodium in this case. So we are going to have 99.68%. So you can see when you approximate this, it is closer to 100%. So this is how you solve questions on percentage composition of elements in a compound. And that will be all on everything about the percentage composition of elements in a substance or in a compound. Attempt this question on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And if this video helped you understand the percentage composition of elements in a compound, don't forget to like this video so more learners can find it. And don't forget to subscribe to Tech and EduSpark Up for more tech content and educational school lessons. And lastly, don't forget to turn on the notification bell so you won't miss any updates from Tech and EduSpark Up. And until next time, keep learning, keep coding, and I will see you in the next one.